Students, welcome back. Now let's continue with our theory of computation subject. In this video, I want to explain you how to convert NFA to DFA. You know this non-deterministic finite automata, how to construct non-deterministic finite automata and the deterministic finite automata. Okay, so the only difference between these two is deterministic finite automata, the transition function is the current state into the input symbol leads to a new state. Okay, it's the next state. And whereas in non-deterministic finite automata, the transition function, the current state and input symbol yields to the multiple paths, that is a 2 power q. So this is the main difference between the NFA and the DFA. So here the multiple paths will be there, here only one path will be there. So now let's see how to convert from NFA to DFA. NFA to DFA is possible, but DFA to NFA it's not possible. So now let's see. Let me take a Q0, Q1, Q2. So I have taken 3 states with input symbols A comma B, B, B. Okay. So this is NFA. Okay, this is NFA. Now I want to convert these NFA to DFA. So the first step I'll take it as the first step is implement the table, construct NFA table by seeing this transition diagram. Construct NFA transition table. So with the help of the table, I am going to convert the NFA to DFA. So what's the transition table for the NFA? So here inputs are A, B and the states are Q0, Q1 and Q2. Q0 is the initial state and Q2 is the final state. Okay. So Q0 on A goes to Q0. Q0 on B goes to 2 states, Q0 and Q1. Now Q1 on A goes to Q0, Q1 on B goes to Q2. Now Q2 on A, no state and no state. So sorry, Q1 on A, nothing is there. Q1 on A, nothing is there. So this is NFA. Now we have to translate it into DFA. I clearly say this is not DFA because a new state is consisting of multiple paths. But our DFA is having only the single path, not the multiple path. So now I want to convert this table into an DFA table. Now translate it. How it is possible, see. So let me again show you here. NFA table was, let me write it again. The transition function A, B, Q0, it's initial state, Q1, Q2, it's a final state, and the input Q0, Q1, and here no state, and Q2. So this is NFA. Now let me construct DFA for this table. Okay. So transition A, B inputs and the initial state is Q0. So Q0 on A, it goes to Q0 only. Now coming to Q0 on B, which is a multiple paths, Q0 and Q1. So let me take this multiple paths as a new state. So I am representing a new state as Q0, Q1. So I am considering this as a new state. It's a single state, not a multiple state. It is let me call it as a single state. So to represent the single state, I am taking these type of brackets. So this is one state and this Q0, Q1, both I am taking it as a single state. So for this, so here Q0 is already implemented, the row is completed. Now take Q0 and Q1 because this is a new state. Okay. So now check Q0 on A. So first check with Q0, next Q1. Q0 on A goes to Q0 and Q1 on A, nothing is there. Okay. So nothing is there. So if something is there, you have to make it as a union. Q0 union Q1 on A. Now coming to Q0 on B. Q0 on B is Q0, Q1 and Q1 on B is Q2. Q0, Q1 and Q2. Means I am taking it union Q0, Q1, Q2. So here Q0 is already implemented. So the new state is Q0, Q1, Q2. So now implement the Q0, Q1, Q2 new state. So the new states you have to take it as, and you have to check what is the next state for this input symbol. So whatever the new state is there, that you have to write in the transition function. That new states becomes the current state, and these input symbols which yields to the next states. So this is a deterministic finite automator. We have to take only the single path. That is a single state. So this complete is a single state. Q0, Q1, Q2. So first Q0 on A. What is Q0 on A? Q0 on A goes to Q0. Q1 on A. Q1 on A, nothing is there. And Q2 on A. Q2 on A is also nothing. Now coming to B. Q0 on B, it is Q0, Q1. Q1 on B, it's a Q2. And Q2 on B, nothing is there. Okay. So Q0 is already implemented. Q0, Q1, Q2 is already implemented. So it's N. So then what is the final state? Here Q0 is the initial state and Q2 they are saying as a final state. So we have to check in which state a Q2 number is there. Okay, here Q2 is present. So let's take this as a final state. So wherever the Q2 is present, suppose if it is present in two states, take two states as a final state. Okay, so this is Q0, Q1, Q2, it's a final state. Let me draw the transition diagram for this DFA. So NFAs they are given. Now I am constructing the DFA transition diagram. So what are the three states? Q0, Q1 is another state, and Q0, Q1, Q2. This is another state. It's three combined, that is one state. Now Q0 on A goes to Q0 itself. Q0 on B goes to Q0, Q1. Now coming to Q0, Q1. Q0 on A. Q0, Q1 on A, on input A goes to Q0. On A goes to Q0. And Q0, Q1 on B goes to this state. Now coming to this state. So this is the final state. And for this Q0, Q0, Q1, Q2, this is one state. This state on A goes to Q0. So from here to here it goes to A and B itself. So this is a state transition diagram for the given for the DFA. Okay, is it in DFA? Yes, obviously it is in DFA. Check here. Q0 on A goes to only one state, that is itself, and Q0 on B it is going to only to one state, not the multiple state. It's only one state. So and here also Q0, Q1 on A goes to one state, a new state, and Q0, Q1 on B it goes to next state. Only one input, for a specific input the specific state will be there. So now this is DFA. So I converted the NFA, means taking the NFA I converted into DFA. Thank you.